Thanks a lot for inviting me to speak. I'm really excited to also learn more about feature stores, which is a part of the ecosystem that is fascinating because of how quickly it's evolving. Um, but what I'm going to talk about today is to bring a slightly different perspective to the conversation. At Gantry, we're working on a different part of the machine learning tooling and infrastructure stack, which we've been calling an evaluation store. And so what I'm going to try to do here is, first I'm going to talk about where I think we are as a field right now in machine learning. Um, and then I'm going to talk about how kind of I see, from the outside, feature stores fitting into that. And then last, I'm going to describe the evaluation store concept that we're building toward and talk about how I think these two systems can work together. Um, Excellent. So where are we as a field in machine learning? So my perception is that machine learning is rapidly becoming a product engineering discipline. Um, and it's not just me saying that. We're in good company for those of us here who believe that. And so first, what I want to do is say a few words about like kind of how I think we got to this point as a field. So brief like history of machine learning in industry. Machine learning has actually been used in industry for a long time. Before kind of like machine learning became the cool thing to do, models were typically run offline in medium or large data sets. And really like the value that companies got out of machine learning was by taking the results of a model that you ran offline and using it to make decisions. So, think about like using a model to help you decide where to build the next McDonald's. And something happened in the 2010s, which which you all are aware of, which is that machine learning became like the cool thing to do. Deep learning explosion happened. All of a sudden, companies were building machine learning efforts or like AI efforts, as many of them would call them, for reasons that, I would say charitably have more to do with the marketing value of the efforts that those companies are producing than they do the actual business value. And so I think we're kind of at the cusp of another wave of like the application of machine learning in industry, which is a shifting focus from machine learning being used to create like POCs and demos to companies really refocusing their efforts on building products that use machine learning, right? So evaluating machine learning teams the way that you evaluate any other engineering team in the business, which is like, does this make our company better? Does it make our product better? Does it make us more efficient in some way? And so the challenge this presents is that, if you want to actually build products that use machine learning in them, it requires a fundamentally different process than what we learned how to do in school. So when I learned how to do machine learning, I was taught a process that looks something like this, right? So you select a problem to work on, you collect some data to help you solve that problem, you clean and label that data, you train a model, you iterate on training a model until you have a model that performs well on your evaluation set. And then at the end, you produce a report, which in many cases is like a paper or some charts. And so I've started calling this flat Earth machine learning because I think like just like thinking the Earth is flat, thinking that your machine learning process ends as soon as you have a trained model, misses like the outer loop. And so if you want to build machine learning enabled products in the real world, you need to think about this outer loop. And the reason for that is that like one way to think about the value that a machine learning model produces is that a machine learning model essentially is compressing some data that you feed into it. And so the value of the model is related to the value of the data that you're compressing. But data in a business context tends to get stale. And in particular, like data tends to change over time, whether it's because the real world changes or because you have breaking changes to your pipeline. When you train a model and deploy it into production once, it tends not to perform well for very long. And so I think like the fundamental shift that needs to happen in order to move from like building machine learning models to machine learning enabled products is adding in this outer loop where you collect the data that flows through the model and retrain the model on it, redeploy it so that your model is able to adapt to the changing context over time. And when this is done really well, it creates like this kind of positive feedback loop, this data flywheel that Jim was describing, right? Where over time, better models lead to a better product leads to better users, or more users lead to more data. And then, if we as machine learning engineers do our job well, more data leads to better models. So I think one implication of this shift, if I'm right about this, is that machine learning teams that aren't able to navigate this transition are not going to be in a very good position over the next 10 years. And so, I think we're already starting to see this a little bit with some of the high profile sell-offs of, arguably some of the most hypey like machine learning enabled companies over the last 10 years. And even OpenAI, where I used to work, I think it's fair to say is like seen the writing on the wall here and has made a pretty hard shift towards being like a product oriented company as they've tried to commercialize GPT-3 and Codex and some of their other products. And I think like maybe the most worrying statistic here for me is, in this kind of like industry survey, a full 20% of companies freely admitted that the main reason that they like started doing AI to begin with was not like they knew exactly what value it was going to produce, but it was that they felt peer pressure that everyone is supposed to be working on this. The flip side of this is that I think teams that are able to navigate this transition are going to create incredible things, right? And so I think like when most people think about the incredible things that machine learning is going to enable, they think about like the high profile use cases, the autonomous vehicles, the real-time translation systems. But I'm almost like more excited about the long tail of machine learning applications, like the MLification of everything. ML running in the background of pretty much every piece of software that we interact with, making the world like just that little bit more efficient or more personalized or more automated. And so what does this actually mean for you as a machine learning team if you want to navigate this transition well? So a few sort of core differences between like machine learning enabled products and this like flat earth conception of machine learning. They often need to run in real time or near real time, not just offline in batch mode. They need to deal with the fact that like most data distributions in the real world are constantly evolving or changing over time. They need to handle messy, long tail real world data, not these like clean academic data sets that were given in school. And then critically, they also need to be able to, in many cases, make predictions that are not always going to be carefully audited by humans before they're shown to users or used to make decisions. And so these shifts imply new demands for our like operations and infrastructure that we use to build these systems. So we need to be able to host and serve models with low latency. We need to be able to retrain models frequently, potentially even continuously. We need to be able to deal with the messy long tail of real world data. We need to be able to like inspect that data in a scalable way, manage these different like slices or subsets of our data that we care about, find edge cases, and make sure those edge cases are properly incorporated back into our training process. And then lastly, if these systems are going to be truly autonomous, we need to have a very high bar for how quickly we'll be able to catch and diagnose problems that arise in the system before the problems kind of manifest themselves too clearly for our users. So the next thing I want to talk about is, as we navigate these changes, what role can feature stores play in that transition? And so the first thing I want to do here is actually, like one observation I've had is that I think for a lot of folks in the industry, probably not for folks in this room, but for let's say other people I talk to in the ML world, there's kind of a lot of confusion about what feature stores actually are and what they do. And so I'm just gonna, for the sake of clarity, I'm just gonna kind of lay out my definition here, based on what I've seen from folks in this room and other folks that I've talked to. So what does a feature store actually do? Like my kind of outside view here is that there's sort of two core roles that a feature store plays, and then there's two things that are often kind of coupled with those things. So the two core roles are being able to define features in a way such that they're able to be computed consistently and at scale, both in the offline world, like when you're generating a training set, and in the online world when you're serving predictions to users. And then the second sort of core use case that I see in like pretty much every feature store or description of feature stores that I've seen is like being able to make those features available to your production system in real time or in near real time. And then a couple of other value props that I sometimes see associated with feature stores, but not always, are feature sharing. So how do we as users discover features and make sure that we're defining features consistently between different models or different teams? And then sometimes monitoring, so detecting drift and detecting training serving skew on the features that we are computing and storing in the feature store. So with that definition in mind, and I'm sure that there's other definitions here that are better than mine. How does that fit into kind of this this like continual machine learning paradigm that is going to be so important for machine learning teams to be able to figure out? So a few things that I think feature stores are like going to be essential for. So in the training process, being able to generate training sets to use to retrain your model in an efficient way and in a reproducible way. It's a really challenging thing to do for a lot of machine learning teams that don't have feature stores, and I think it's a problem that feature stores can just solve. Deploying features, right? So again, like making features available in near real time is an essential part of being able to serve predictions in near real time. In some cases, if your feature store allows you to monitor features, the feature store can help with that. And then lastly, like the mechanics of closing this loop, right? So how do you actually get data back into your system so that you can retrain on that data? I think a natural place for that data to be collected and used to retrain is to essentially shove it back into your feature store. So those, like, I think that is like a large chunk of the kind of like core infrastructure problems that exist here that feature stores can really help with. So the next thing I want to talk about is a few places where I don't think feature stores are going to help as much, at least not with this conception of what a feature store actually means. So a couple obvious ones are like actually, doing the training and serving of models themselves. So those are infrastructure pieces that, like, if you build or buy a feature store, you need to find somewhere else. The rest of these kind of have a different flavor. So one thing that I think is really hard for a lot of machine learning teams to do right now, that feature stores, can help with in a way that I'll describe in a second, but won't really be able to answer for you, is making some of the kind of core operational decisions to help you move models and data through this loop, like from stage to stage. So for example, when you train a machine learning model, you generate a training set using the feature store, you fit a model using your training infrastructure, and then you evaluate that model, potentially using your training infrastructure, maybe your feature store, I don't know. But then how do you, as a human, make a decision about, like, okay, is this model actually good enough? Like, is this actually ready for me to deploy? Similarly, like maybe you, if you're building your infrastructure well, maybe you have a paradigm where you run a shadow test or an A/B test before you roll out a new version of the model. So how do you know whether the new version of the model that you're thinking about rolling out is actually better than the old one? Like, is it really performing better, or did it just perform better offline? Again, I don't think feature stores really solve that problem for teams. You can collect the data to retrain your model, and you can feed that data into your training system performantly using your feature store. But a feature store by itself, I don't think, can really help answer the question for you of whether your model actually needs to be retrained. And then, I think a critical part of closing the data flywheel is, in many cases, we don't have the budget to collect, label, and retrain on every single data point that is flowing through our production system. And even if we have the budget to do it, it might not be the most efficient thing or the best thing for model performance. So deciding what data we should be collecting, what subset of that data should we label, like how should we spend our labeling budget, and what subset of that labeled data should we actually train on. I think, again, our questions that a feature store alone is not well poised to help machine learning teams answer. Okay, so let's try to like draw some general conclusions about these bullets from the last few slides. Like, where are feature stores really helpful, and where are they, maybe on their own, not fully solving the problem. And so I want to draw a distinction between infrastructure and ops. And so I think, like, kind of one of one of my pet peeves in how people talk about like ML ops as an emerging field is that I think there's a lot of uh, I think people kind of use it as an umbrella term for anything having to do with helping make production machine learning systems. But I think there's actually a semantically meaningful distinction to be drawn here about what we mean when we say operations. Um, and so the distinction I'm going to draw is to think about infrastructure and ops separately. So when I think about infrastructure, I think about kind of the like core computing tools that allow us to do the things that we need to do in our machine learning system efficiently and at scale. So, a training system, like a system that allows you to basically train a model on a large number of GPUs efficiently, share a pool of GPUs efficiently across a large number of workloads, to me is kind of a core piece of infrastructure, right? It's about like, how do we actually do the thing that we need to do as part of our ML system? Ops, on the other hand, I would define as like kind of the decisions that we make about how to use the infrastructure that we have to achieve our end goal, which is to build machine learning systems that make our products amazing and help us serve our customers' needs. So I kind of think of feature stores as being like primarily a piece of infrastructure, right? So like the primary goal of a feature store is to be able to compute features consistently offline and online at scale and make those features available in near real time. Now, I don't think a feature store, like at least most of the feature stores that folks in the room are building, is entirely an infrastructure tool. I think it's an infrastructure tool that bleeds into ops. And so in particular, I think like these features of the feature store of like being able to share and monitor features are really like core operational tools. So coming back to this question of like, what don't feature stores help with? A lot of these questions, putting aside the training and deploying models piece, the rest of these questions, these like core operational questions, are the types of questions that an evaluation store is designed to help teams answer. So what is an evaluation store? An evaluation store, as we define it, is like a single source of truth for model quality metrics. And these are both metrics from the online world, like your business metrics, how well is your model performing in the real world, and the offline world, like how accurate was your model on all of the evaluation sets or subsets of your evaluation set that you care about. To make this a little more concrete, what are the inputs to an evaluation store and what are the outputs? So what flows in is like basically raw data that gives you context on how well your model is performing. So it's raw data from your model training and evaluation process, from your production ML system, but also from the rest of your machine learning system. So from your user-facing application and potentially other business metrics. All that raw data flows into the evaluation store. It is not necessarily stored there. So the evaluation store is not meant to replace like a feature store or a data warehouse or a data lake. It's meant to build on top of those things and use that kind of like raw data storage to compute evaluation metrics, like how accurate is your model, how frequently are users clicking on the recommendations that you make, and expose those to downstream systems in a way that allows you to use them to make decisions, like use them to decide whether to promote a model into production, whether to whether it's time to retrain the model or not. Build workflows on top of those decisions, like, hey, maybe if we see this much performance degradation, we should just automatically kick off a training job because we're probably going to want to deploy a new version of the model in production. And then also provides you lineage into those metrics. So for a given metric, if my accuracy dipped by 5% over the last day, you want to be able to drill down and say like, okay, maybe there's something in my data that's causing that. And so the critical thing to understand here is like evaluation stores like are meant to provide the link between these metrics and the data that corresponds to the metrics. They don't necessarily need to be the place where the raw data itself is stored and where the raw computation is run on it. So what do we think this can help with? Maybe this is obvious from the past few slides, but reducing friction in your organization. So helping make, like, machine learning is an interdisciplinary game, and collaborating on machine learning systems is really challenging. And we think the way that teams should collaborate on building machine learning systems is through the lens of metrics. And that's exactly what an evaluation store can help with. Deploying models more confidently, and when you deploy models, making sure that you're able to catch issues with those models more quickly so you can roll things back. And then lastly, like helping with this, the operational side of closing the data flywheel. So helping you capture and label your production data more intelligently so you spend less money on it, and making your model better over time by picking the right data to label and retrain on. So keeping an eye on time, I'm going to skip through the next few slides.
You're okay for time, Josh. It's fine.
I'm okay for time?
You got 10 minutes. Cool. You got 10 minutes. You're fine.
Oh, perfect. Yeah, okay. So maybe I'll go through these quickly then, just to make this a little bit more concrete. But so like what could you actually, like concretely, what kinds of questions could you use an eval store to help answer? So, a query of an evaluation store consists of like, let's pick some models that we're going to query, some metrics, some slices. So like some concrete subsets of our data, like maybe we just care about this metric for users between the ages of 18 and 35. And then the window of the data. So for example, you can use an evaluation store to run a monitoring query. Like what was the importance weighted average drift across all of my features in my production model in the last 60 minutes? So this is like a type of query that has more overlap with the feature store. How much worse was my accuracy over the last 7 days than it was during training? These are the types of queries that start to get a little bit trickier to figure out how to formulate in a feature store because, because like comparing predictions and actuals is its own separate problem. How do all the metrics compare between model A and model B across like all of the subsets of my main evaluation set? So kind of a testing query, or a query I think would be difficult to run in a feature store today is like, how do my business metrics compare between model A and model B in the last 60 minutes? So being able to answer all these types of questions about how well my model is doing in one place. And so coming back to this like infrastructure versus ops distinction, I see an evaluation store as primarily an ops tool, like a tool that is meant to help you make decisions about how to use your feature store, your model training system, and your model serving system to better meet the goals that you have as a machine learning team. And it's an ops system that bleeds a little bit in infrastructure because it also helps you compute metrics efficiently at scale. Okay, so I want to just say one word about how this works, just to make it maybe make the difference a little bit more concrete. So like here's kind of like a sketch of what like maybe your entire production machine learning system might look like. Like I think a lot of times when we think about machine learning, we think about like studying a particular model or studying maybe even a particular feature that is an input to that model. But in a production machine learning system, you often will have like, maybe it's more productive to think of it as a graph. So you have a request that comes in from a user, use that request to query your feature store or pull some features. Some of the context in that request might not flow through the feature store. For example, maybe there's an image in that request. That's also an important input to the model. And then the model makes a prediction. In the real world, oftentimes like teams will build pipelines of models. So the output of that model might serve as the input to another model that produces another prediction that's potentially combined with some context from the request to produce a response to the user. Then at some point in the future, like after all this has happened, you might get some feedback on that prediction. Like, did the user click on the recommendation you made? What does the labeler say the correct response should have been? Then what an evaluation store helps you do is combine these feedbacks, combine the feedback with your response to compute a score function, like what is the squared error between this prediction and the response? And then take this entire graph, like all, from your request all the way back to your response. And like conceptually, this isn't actually what's happening on the back end, but conceptually you can think of it as like sort of flattening this graph into a table. And then taking, individual scores in this table or individual like columns, like feature columns, and aggregating them over a window to compute a metric. And so the reason why I think this is maybe a productive way to think about it is because like other sort of table operations that you might want to do on a system like this are also very applicable. And in particular, like computing, hey, what is the value of my metric when, like when this input feature is within this range, and the response that I sent back to my user is true. So being able to filter this table is also a pretty important aspect of what an evaluation store allows you to do. So I think kind of natural question maybe for folks in this room is like, shouldn't this just be the job of the feature store? So a couple of reasons why I think it's productive to think of these as separate systems. One, as I kind of alluded to before, not all important data for understanding the context of your machine learning system will flow through the feature store. So business metrics tend not to flow through the feature store. Metadata. So oftentimes you have metadata that does not actually form an input for one of your models. Maybe like for regulatory reasons, it can't even form an input to one of your models. Like maybe it's a protected attribute like gender, but still being able to slice along that attribute and understand how performance differs is really helpful to making decisions. And then unstructured data like images and text, I think fit, like in my opinion, a little bit less cleanly into the feature store paradigm. So not all data that you need in order to like answer eval store questions is present in the feature store potentially. But a deeper issue than that, I think, is that like, I think it's tempting to think of like monitoring our machine learning system as, monitoring the features that make up that system. But monitoring your machine learning system is not the same as monitoring all the features. So for example, performance drift is more important than feature drift. If you're able to tell like how well your model's actually performing against model metrics or even better against business outcomes, that's more informative to you as a model developer than it is to know whether KL between your feature and its distribution and training is like above some arbitrary threshold. A poor quality feature, so a drift threshold that you set on one feature has really different implications depending on which model that feature is being put into. So, like models have different sensitivity to different features, and a model might be very robust to large drifts for one feature, and a different model might not be. Operationally over time for machine learning models and machine learning systems, it's very common to like add features, remove features, change the types of features, and those types of things. But there's certain things about like the model performance that are productive to view consistently over time, like the model performance. And then lastly, like, I think in the example that I showed before, it's like thinking of your machine learning system as a graph of different operations. How do you tell like if there's like some performance outcome that is not that you're not achieving, like if your business metric is not doing well, how do you ambiguate across the different steps in your pipeline? Is I think difficult to do like if you just view each of the steps of the pipeline independently. And then lastly, like I think one reason that's productive to think about these tools separately is because there's a lot for us as an industry to build here on the infrastructure and on the ops side. And so to some degree, like things that can be separate should be separate. And so for example, like the types of tooling that we'll build around evaluation stores, like to help you analyze model performance, are very different than I think what are natural to build as part of a feature store. And the query patterns themselves may be different as well, right? Like these types of sliced queries that I was describing, where you look at accuracy over, for a particular range of a feature, are like absolutely critical to being able to do the job of an evaluation store well. But I don't see discussed as much in how people talk about feature stores today. So the last point I want to make is that, just because these two things are different doesn't mean that they shouldn't work together. So evaluation stores are, like my view is evaluation stores are fundamentally ops tools, but they're ops tools with a bit of their toe in the infra world because we need to be able to compute these metrics at scale. Feature stores, on the other hand, again, in my view, are fundamentally infrastructure tools with, a bit of their toes in the ops world. I think one concrete way that these two tools can work together is that, I don't want to reproduce all of the things that feature stores do well. And so as like developers of an evaluation store, we would love to leverage feature stores for storing raw data and for query workloads of the raw feature data, so that we don't have to rebuild that functionality. On the other hand, the goal of feature stores, like almost definitionally, is to like study features. I think the value that eval stores can bring to feature store developers is to bring the context of the model and of the broader machine learning system that model fits into. And so I think like, for feature store developers, the way that eval stores can help is by helping your customers use the fundamental infrastructure that you're building more effectively. That's all I have. Last thing I'll say is, again, I'm working on a startup called Gantry that's building kind of exactly what I described here. We're currently onboarding beta users. So if you're interested in either collaborating, like if you're a feature store developer and you're interested in kind of working together on some of these things, we'd love to hear from you. And if you're maybe a feature store customer, we'd love to show you kind of what we're building and talk about how it might fit into, how it might help you use your feature store more effectively.